Hello, I'm Dr. Arthur D. Kemp, the Hammond Doc. I want to show you some equipment that I have over here. Now, this is a Syncor LC101 capacitor inductor analyzer. It's a wonderful piece of digital equipment, but I use it daily in my shop here to test the value of capacitors as well as to test leakage, for DC voltage. And it's great for doing those things, except there is one limitation. When it comes to the testing for leakage, the chart here goes down only to 1 microfarad on up. So if I want to test a capacitor like this that is 0.1 microfarad, 600 volts, while I can test the value of the capacitor with my Syncor LC 101, there is no information in the chart for determining leakage on the LC 101 for a cap like this, 0.1 microfarad. So what could I do? Well, I said, let me look on my shelf and see if I have another instrument that would do that, that is test for leakage. And of course, I have several instruments on my shelf. Heathkits, I got a couple of Heathkits and an ICO that'll do that. And this is one of my vintage pieces of analog test gear, the Heathkit IT-28. Now, and I'm gonna show you how this thing works. It's beautiful. Here is you see a couple of capacitors here. They're just connected by some cement here or glue. So, but I have the leads connected by alligator clip to both legs of this capacitor. So I'm looking at the bottom capacitor. The top capacitor is already it's already cut off the lead to it, the leg to it. So let me just get rid of that. So this is what I'm dealing with. Okay. Now I'm going to lay that down over here, just to get that away from me. And I'm going to turn on. I'm going to set this on. It has 3 settings. I'm going to set it on the paper, mica, etc. type capacitor. I'm going to set this at times 1. I'm not going to go with times 0.01 because I'm dealing with a 0.1, not the 01. So I'm going with 0.1. That'll be C. Set it there. I'm going to set it on, it's set on discharge right now. I'm going to set it on bridge. Alright? Because this is a capacitor analyzer. It's called a capacitor checker. Some call it a bridge. And then I'm going to turn it on. And I'm looking at this line here. And this is the 0.1 microfarad. Times 1 is 0.1. Okay? And then it's going to turn on in just a moment. There it is. See the light, green light come on. Now the light is, the eye is closed on it right now. Let me turn this fan off so you can hear me. Okay? So the eye is closed on this right now. what I'm going to do is turn the dial. If this capacitor is good, then what's going to happen when I get to the point 1 is the eye is going to open, and it does. As you can see, the eye is open, which indicates that the capacitor is, in terms of the value of the capacitor, is good. Now, I can also test for leakage. So I'm going to leave things set as it is. Come over here to discharge. Now, I have the voltage knob set at 600 volts. I'm going to send 600 volts of current through this capacitor. So I don't want to touch it. So here we go. And it just very briefly it turned off, and then it went back on, this eye here. But you see the eye is open, which tells me that this capacitor is not leaking DC voltage, and it is a good capacitor, even though it's an old capacitor. I'm gonna hit this to discharge it. Come back here and discharge it now. So it's discharging. So in other words, this is a good capacitor. Now, it's a 1960 capacitor, and it's a Sprague, and these things hold up for a long time. 60 years. I mean, this thing is probably 55 years old or so. The amplifier that this capacitor came out of, and the capacitor itself. So when I have amps that have this Sprague in it, and they belong to me. I may leave the Sprague cap in, especially if I test these things and I see this type of results, where the value is testing good and there's no leakage. Then it's going to do the same thing as a brand new cap. And now, what would be the purpose of putting this in? Well, this is a orange drop, now sold by Cornell Dubiar. So in terms of reliability, you have more confidence in this than this. But this particular one is still a good it's still a good capacitor. All right, so that's it for this video, and until the next one, this is Dr. Kemp, the Hammond Doc, saying to you, peace out.